there's going to be 2 compulsory and 1 which is going to be a choice. So the 2 questions that are going to be compulsory are linear regression and probability, okay? And then the choice will be, so it'll be question 1, which will be linear regression. Question 2 will be a probability question. All right, hang on. Right. Yeah. So the linear regression and probability, I'm going to go through with you a little bit later into the presentation. I'm going to start with the grouped and ungrouped data, which will be either question 3 or question 4. Okay, so you will make a choice, class, between either ungrouped data or grouped data. So what I'm going to do for you is I'm going to show you the kind of question 3 questions and then show you the question 4 type questions. And then hopefully by now you will have made a choice which way you're going, but otherwise you can actually make that choice as we're going through it. Right, so first of all, let's start with our data. So we're going to be looking at random variables. We're talking about summarizing data, class. So we're talking about a descriptive statistics. So chapters 2 and 3 in your book. These questions relate to your question 3 or your question 4. Now, when we are talking about chapter 2, we're talking about how we summarize data. And by summarizing data, class, we're talking about how we're going to either draw it pictorially or how we're going to summarize it into a numeric frequency distribution. A question 3, ungrouped data, will generally have some things like pie charts and bar charts as well, or not as well, included in the question. And a question 4 will generally have a numeric frequency distribution. So I'm going to cover those 2 areas first. Then I'm going to go on to the calculation areas. So the first thing we must understand is that we've got something called categorical data, and we have something called numeric data. Now, categorical data, class, is data that is categorical in nature, which is qualitative, basically. Qualitative data means you are going to either use a bar chart or a pie chart to show it, all right? And that is going to be a question generally in the question 3 with your ungrouped data. So you'll have your ungrouped data and you'll be asked to calculate means and medians and percentiles and stuff like that. And then the second question will generally give you some data which will require you either to draw a bar chart or a pie chart. We'll start with that. Then we're going to go through to the numeric data. So to start with, I need to just make sure that, sorry, let's get this sorted here. We're just getting people coming through now, no problem. Yeah, let's just admit. Right, there we go. And the question 3. So you'll see from here on out, students, I've got a yellow for a question 3, and it'll be a green for a question 4. Now remember, question 3 and question 4, you are going to choose between one or the other, okay? Question 3 will generally ask you for a bar chart or a pie chart. They will give you data that's, for instance, in this table here. And for instance, Checkers and the store Checkers, Pick and Pay and Spar, how many people visited, and then the percentages here. So it'll be 10 out of 30, 17 out of 30, 3 out of 30. So you can get a bar chart that requires you to look at the raw data, or you can get a bar chart that requires you to look at the percentages. Class, check what they're asking you. Generally, they'll ask you for the raw data. So what do you need to make sure to get your maximum marks is that you need to ensure, for the very first and most critical aspect of this is you do not allow the bars to touch at all in any way. Even in your first bar, which is Checkers here, we started a little way away from your vertical axes. So you have space bar, space bar, space bar. Okay, so you will have a title on top. And then for each bar, you will, for instance, here you've got, it'll either go to 10 or 33 1/3. You please make sure that you label it at the bottom checkers, pick and pay, and spar, or whatever it happens to be, and you put the 10 or the 33 and a third at the top. So you label it at the bottom, you put the percentage at the top or in the inside. You don't have to use rulers and stuff, but make sure you put all the relevant details onto the chart that is required. Generally, they ask for bar, but sometimes they ask for pi. Please, could that students, please mute your mics, please, all of you. I'm getting feedback here. Thank you.
When it's done, put chocolate of your choice. Here I'm going to use.
Please, will that student mute their mic? I'm getting a recipe. I'm getting recipes through here at the moment. Okay, thank you. Right, so that's your bar chart, and make sure that it has a title and that the bars do not touch and that the data is included. That'll be a question 3. Or they can ask you in question 3, they can ask you to draw a pie chart with the same set of data that I've shown you here. What do you need to do? It'll generally be a percent. So if they give you 10, 17, and 3, you will calculate the percentages up to 100. Then you'll draw your pie by hand, really, unless your lecturers have told you specifically they want to have it done cleverly. And then you're going to, you'll show in each of the sections here, for instance, pick and pay is 17, you're going to have 17, or in fact, the percent. Similarly here, similarly here. Please again ensure, class, that you put a title on it. Let's think. Hi, the video is not showing. Sorry, Jessica, it should be. I think everybody else can see it. Just reboot or go back in again, unless nobody else can see it. I think everybody else can see it. Right. So what do we got? So remember, again, I'm going to keep coming back to this. You're going to have a question paper in front of you that has 4 questions. The first 2 questions are going to be compulsory. They're going to be linear regression and probability. Then you're going to have section B, which is question 3 or question 4. Question 3 will be ungrouped data, of which the question will either be bar chart or pie chart. And then question 4 will be grouped data, and there we will be dealing with a numeric frequency distribution. So these are very easy to get marks for, but just make sure you title them. You put a title up with your pie chart. Make sure you do the correct chart. And of course, with your bar chart, please, class, please ensure that your bars do not touch. Right, now a question 4 for a drawing or a numeric, or putting, it'll be the second question. Well, a question 4 will generally ask for a numeric frequency distribution. What are they going to do? What are they going to give you? And how are you going to do it? Right, so the first thing you need to do and remember is that by drawing, and I'll show you an example of this now, is by drawing up a numeric frequency distribution, you are going to be drawing, and I'm just going to go forward and then I'll come back again. This is a numeric frequency distribution, the thing that you have in front of you. You'll have intervals, frequencies, and perhaps percentages if they ask for it. Okay. Here I've just got the age interval, so that would be 19 to just under 29, and 29 to just under 39, 39 to just under 49, 49 to just under 59, etc. Right, now, so the first thing is, and I'm going to go back quickly, is that those intervals must be equal in size. They will give you the interval width in the question, all right? And they'll tell you where to start, but please make sure your interval widths are equal in size and the interval laps do not overlap. In other words, if you've got an interval from 20 to 30, you'll go from 20 to just under 30, and then the next interval will start at 30 to just under 40. Okay, that interval width would be 10. It'll be consistently 10, and the interval limits will not overlap. All right, so how are they going to ask it to you? They're going to give you a set of data. Generally, and this is a question 4 question class, they're not going to give it to you in a long line like that. They'll give it to you in like a little blocky of 20, generally 20 data points, okay? And it'll come out in a block of data, and it'll be the second question in question 4. And they will say to you, please draw up a numeric frequency distribution with an interval width of maybe 5 or 10. They will give you the interval widths. and they will indicate the interval with which you start. So please don't just start at 0 to 10 if the first data point that you are looking at actually is 20 or something like that. That's just a waste of time, and it's not going to add anything to your mark system. So check where they ask you to start. And make sure that the interval width is equal, and that it covers all the data you are going to be putting on. So now you've got this data stream. As I said to you, it can be in a stream of data, or generally in the questions they give you, and you've probably seen them by now, they comes up in a block of data. And what do? They will give you an interval width of, say, 10 to 20 or 20 to 30. You then will count the number of data points in each of those intervals. So let's take this as an example that we have in front of us. The age interval width is from, we're starting at 20 to just under 30. For instance, that's what you would say. Now we're going to count the data points that we can find there. So what data points kind of lie between 19 and 29, be 29 to 39. I'm not going to do all of them, but let's just do the first one. So kind of 19 to 29, we're going to have a 23 in there. Yes, 1. And this data is range. So 1, 2, 3, 4, 5, 6. Okay. So we got 6 data points there. They lie between, in this situation, it would be 19 to 29. The next one will be 29 to just under 39, 39 to just under 49. So when you get that data, you will count the number of data points that lie in that range, okay, in that interval. They will generally give you the interval range in your question. They will say to you, for instance, the interval will be 10. And you should start at 20 to just under 30, or whatever the case is. So read it. That would be a question 4. That'll be a second question in question 4. Remembering, class, that this is not a compulsory question. You will either have a choice between one of these, or a choice between one of these, or a bar chart or a pie chart. It depends on what you prefer. So those are question 3 and question 4, type of graphic description type questions. What I'm going to go through to move on to now, and then they could at some stage, but I haven't seen it, so I'm going to be honest with you, to draw a histogram, but I've never seen them ask for it. They generally ask you to draw up a numeric frequency distribution, and that would be a question 4. Okay, I've never seen a histogram, so I don't particularly think you should concern yourself with it. Right. Now we're going to do question 3 type question, which is now going to be coded yellow, and a question 4 type question is going to be coded green. Okay. As we go through these questions, or as I go through the learning unit with you, okay, then I'm going to point out which is a question 3 and which is a question 4, so that you can kind of be able to orientate yourself. Right. The first sets of measures that they can ask you, either in a question 3 or in a question 4, is the ability to be able to calculate the mean or the average. Now, they will give you this formula in your formula sheet, and what are you going to do? So, for instance, if you have a data stream of 12, 13, and 14, they will probably give you a data stream of up to 11 data points. Okay, so they're not going to give you something small like this. But the first thing you're going to do is you're going to sum up all your data points. And please do it, and make sure you do it carefully. Your calculators can do it for you. Just don't make a silly mistake, because sometimes this number will carry forward, and I will show you where it carries forward too when you will calculating your standard deviations and variances. So now we are looking at question 3, which is now color coded yellow. And one of the first questions they will ask you is the calculation of an average or of a mean. Okay, so you calculate, so there will be a stream of data. It'll be one long line, because it's question 3. If it is a question 4 data class, it's called group data, and it'll come in a numeric frequency distribution. So the data that you will see in a question 4 will come in one of these tables. A question 3 data will come actually in a stream of data like here, except it'll be horizontal rather than vertical. The first thing they will ask you for a question 3 is to calculate an average. You'll add it all up and divide by the number of data points. Generally, class, they give you 11, but always count them, make sure. Group data, they can ask you for a mean. I'm going to come back to this a little bit later. I don't want to do the calculation now because it won't make a lot of sense to you. So I'm just going to continue with the kinds of questions they're going to ask you for both question 3 and question 4. Group data at the moment, I'm going to leave out in terms of the mean. I'm going to come back to it. The next thing they can ask you for in a question 3 or a question 4 is a single data, is a median for single data. Now, class generally, they give you an odd number of data points, okay? They generally give you an odd number of data points. They generally give you a data point series of about 11, okay? That's why I said as well with your mean, just make sure they've given you 11. If they are asking you for a median calculation on your single data, then what you are going to do, and median, of course, means halfway. So you're going to take this particular formula and you're going to get 0.5, which is half, because the median is half of your data points. And then you're going to multiply it by the number of data points. Now, in this example, there's 1, 2, 3, 4, 5. They will give you more than that. They'll probably give you 11. So you will take 0.5 multiplied and then open bracket 11 plus 1, okay, in your test. In this example, I'm giving you 5. And then you will see it says 5 plus 1 is 6. Remember, BODMAS, you're going to do your brackets first. Then you multiply by a half. So 6 multiplied by a half is equal to 3. You will then count to position. That's the position. Hey, that's not the value when we're finding a median. And then you will count to 1, 2, 3 because that's position 3. And the value occupying that position then becomes number 16. That is the data point you put down in your paper, okay, because they'll be asking for you for the value of the value of the median position. If the data point is odd, which it generally is, you are going to take the number of data points, you're going to add 1 to them, so that would be 12 multiplied by a half will give you 6. So generally, rule of thumb, and again, class, you must count your data points. Generally, as a rule of thumb, in the test or the exam, you will look at a median position of 6. Why? Because you have 11 plus 1 data points, and then you're going to find the value of the number occupying position 6. In this example, we had 5, so we were looking at the value, because 5 plus 1 is 6, of the value of the value in position 6. Okay. Right. Okay. So with even, I won't concern too much myself about it. I would rather you make sure you remember the calculation for the odd numbers. So that's median for single data. That's a question 3. So when you open your section B, you'll see a stream of data for question 3, a single stream of data, and the questions below will probably be calculate mean. It could be calculate median, or it could be, when we get a little bit later, calculate a percentile or a quartile, but we'll get to that. Moving on, we are then going to a group 4, a question 4. A question 4 is in green, and this would be, remembering again, class, you are going to have a choice. Then you are going to, if you wish to, you will be given this formula, which is the median calculation for grouped data. Okay. Now remember what I've said to you in question 3, they'll give you one long line of data. In question 4, they will give you a table, just like that. They won't necessarily give you the cumulative column. Eh? So you are going to have to put the cumulative column in, and I'll explain why in a minute. So now we have this data stream, or this not data stream, we've got a table of data. They will give you whatever happens to be up the top, and what happens here is time in this instance and frequency. So that will be given to you. You won't have to calculate that. The only time you would calculate this table, class, is in a question 4 second question where they say calculate a numeric frequency distribution. This will be given to you if you are asked to calculate a mean or a mode or whatever. These formulae will be given to you. Now, the important thing is to know the aspects, or what each of these things in the formula mean. This O is basically the lower limit of the median interval. Okay, that's a low, and I'm going to go through it first, what they mean, each one, and then I'm going to show you how we find it. So that's the lower limit of the median interval. On the top here, you'll see a C. C is the interval width. N is the number of data points. Okay, and that means you add up your frequency column. So there's 30 data points here because these are the data points that have been counted. Then minus the frequency, the cumulative frequency class, the cumulative frequency of all the intervals preceding the median interval. Okay, now that's quite a mouthful. So the first thing you're going to do is, if you are going a group 4 question, and remember, class, while I'm thinking about it, you can't do one group 3 and one question 3 and one question 4 question. You can't pick and choose. You either do question 3 or you do question 4. If you get halfway through question 3 and you decide you want to do question 4, that's great. Remember your time, but also make sure you cross out question 3 completely. Otherwise, we are, as markers, we are expected and we are asked to mark the very first question. So if you get halfway through and decide to change, that's great, but make sure you cross it out so that the marker knows he goes straight to the whatever question you're going to. All right, so be aware of those things. Don't mix and match questions between 3 and 4. You either do 3 or you do 4. Right, so you'll be given this table here. And the very first thing you're going to do if they're asking for a median calculation is to provide yourselves with a median, with a cumulative column. So what is a cumulative column? So there's 3. You're going to put 3 in there. Then you go 3 plus 5 is 8. So this is a cumulative column of all of those data points. 3 plus 5 is 8. 8 plus 9 is 17. 17 plus 7 is 24. 24 plus 6 is 30. Right. Now, that 30 must, of course, logically must be equal to the sum of your data points. Now, the next thing we need to work out, how do we understand where the median interval is? The median interval class, and this, because that's asking for the lower limit of the median interval. So the first thing we must remember is that the median data point is halfway in your data points. Median is halfway. So you've got 30 data points, okay? So we're looking for the data point that is halfway, which means you take 30 and you divide by 2. So now we get 15. Now we got a number 15. Now what are we going to do with number 15? We're going to say to ourselves, where does 15 fit in our cumulative column? Because we're looking for where the 15th data point sits, and then that is your interval. So does 15 sit between 0 and 3? No. Does it sit between 3 and 8? No. Does it sit between 8 and 17? Yes, it does. So in this interval here, okay, because that interval goes from 3 and ends at 8 there. This one kind of starts at 8 and goes to 17. So this interval contains position 15, data point 15, should I say, which is the median of that data cohort. So now you've got the median interval. So now you can immediately go to the lower limit of the median interval, which is 30. So now you can stick 30 in there. Plus, but you don't do anything else at this stage. Remember, this is a separate calculation to that. Now you can go in and go fairly quickly. C is an interval width of 10. So you put your 10 in there. Then it asks you for n divided by 2, which is the 15 you've just looked for. That's your median data point. So that's 15. That's n, which is 30 divided by 2, minus the frequency class of the cumulative frequency of all the intervals below your median interval. Now, this is the median interval. So what they're asking for is what's a cumulative data count of all the intervals below that. So that, you know, is 3 plus 5, which is 8. So that's where your 8 comes from. All over 9. What is 9? 9 is the frequency of the median interval. So you now have got all your data. So you work that one out, and then you add it to 30 right at the end, and you get 37.78. Now, class, here is a trick, and no problem. I'll do that right now. and I'll get there. But I want you to see 37.78, all right? That falls in the median interval between 30 and just under 40. So if your number here does not fall between 30 and just under 40, you've probably made a mistake. So make that as a rule of thumb that this number must fall in this interval. Okay, and that applies for all the calculations. Right, now a student just requested me to, how did we find the median value again? All right, so remember the median position, the median data point is your middle data point, okay? Your middle data point. And here we have a set of data which runs from 0 to 30. So what is the middle between 0 and 30? It is 15. You take 30 and divide by 2. Once we've got 15, then we can go and along our cumulative column and identify our median interval. Okay, everybody happy? Yeah, okay. If you're not, shout, I can go over it again. Okay, so we've done median for ungrouped data, which is question 3. We've done median for group data, which is question 4. Now, question 3, modal value. In this class, they're not going to ask you because it's a question of eyeballing. And the modal value is the most frequently occurring value. So if the number is replicated or is repeated, that's your modal value. Now, it doesn't require calculation. It doesn't require anything, actually. All it requires is for you to say, hey, see, there's a 10 and another 10. That's my modal position. So they're not going to give you a mode for ungrouped data, okay? Because really, it's just a question of eyeballing it. But they could very easily give you a modal calculation for grouped data. So if you are going the question 4 route, okay, then you are going to perhaps be needing to understand how to do a calculation for modal values. Now you've got this big hairy looking formula here, which I'm going to go through to the next page on and explain it to you. It looks a bit better here. I'm still using exactly the same data set as I did for the group data on the median values, except now I'm going to be using the modal value calculation. Now it's completely different from your median calculation. This will be given to you in your formula sheet, so please don't worry about it. What they don't tell you in your formula sheet is what each of these things mean. So now you need to be able to know. Now, the thing in the front always on these calculations for group data is when it says O and says, for instance, MO or ME, that is the lower limit of whatever the interval is, okay? The lower limit. So it's one of those numbers along there. Plus, and then we have C. C is always the same. It is your interval width. FM is frequency of the modal interval minus, and then this one runs together, frequency of the interval below it or preceding it. Okay, this is the frequency of the modal interval multiplied by 2, but only that is multiplied by 2, minus the frequency of the preceding modal interval minus the frequency of the interval above it. Okay. Now, the first thing I would suspect you would ask yourself is, how do I establish what the modal interval is? Class, the modal interval is the interval with the highest frequency, the most numbers. Okay, so that is 3, but there's a 5. There's 5, but there's a 9. Now, what about that? Is there anything higher than a 9? No. Therefore, 9 becomes your modal interval. Once you know your modal interval, you don't need the cumulative column for this calculation. Once you know that this is the modal interval, because it's got the highest number of data point or frequency of data, then you go there. That is the lower limit of the modal interval. Right, so let's go and see how we now go and do this. Lower limit of the modal interval is 30. C again was 10, correct, class, if you can remember that. And let's go back quickly. What are we looking for? The frequency. What we really now need are the frequencies of the modal interval, the one below it and the one above it. And then let's remember those numbers. So there's the frequency of the modal interval, 9. There's the one below it, 5. There's the one above it, 7. So we must remember 9, 5, and 7. Where do they fit in? Interval 10. and the frequency of the modal interval was 9. In other words, the number of data points in that interval minus the frequency of the one below it, the one below it, which was 5. Shut your brackets there. Right, downstairs, 2 multiplied the frequency of the modal interval 9 minus the frequency of the preceding one, which, as perhaps we remember, was 5, minus the one above it, which was 7. Okay, now we do that calculation, and they're fairly simple, but you can make a mistake if you're not. If you add this to that before you do all this calculation, you could actually make a mistake. So class, please don't do that. Right, and you do it all together and you get 36.67. Again, class, remember your rule of thumb. This number must fall in the modal interval, which it does, okay? So it falls between 30 and just under 40. So we kind of write that it actually works. That's your modal position. Now remember, you're looking at 3 calculations in measures of central tendency: the mean, which is the average, the median, and the modal value. Okay, so we've covered all of those with the exception of the mean for your grouped data, and there's a reason I've left that out for the moment. What can they give you, class? And this is important at this stage. Question 3, they will probably definitely ask you for a mean calculation on the ungrouped data. And then they may ask you for a median, or when we get to it, they could ask you for a quartile calculation or a percentile calculation. All right. With grouped, they will ask you mean, they could ask you mode, because there's a calculation there. They could also ask you a quartile when we get there. So now I'm just drawing up with the kinds of questions they can ask you in each of those 2 types of questions. So question 3, ungrouped. Question 4, grouped. You are going to make a choice between the 2 of them. Right. So as I just introed you to it. So here is quartiles. It's in yellow. So we are looking at a question 3 type of calculation. Now they can ask you 2 types of questions. So you're going to have your data stream at the top of the question. They're probably going to ask you for an average or a mean calculation on that data. And the next one could be a median. Or class, they could ask you either a first or a lower quartile or an upper quartile calculation. All right. They're not going to ask you middle, because you know what that is. That's a median calculation anyway. Okay, remember this. I gave that to you when we're looking further back in the median calculations for ungrouped data. So they're not going to give you that. They're not going to ask you for if they've asked you for a median, they're not going to ask you for a middle quartile, because that's the same calculation. But they definitely can ask you for a low quartile or an upper quartile. Okay, so what I want us to do now, it's in your book anyway on the page in descriptive stats in chapter 3 somewhere. These are the calculations I need you to remember and to be able to use. This, of course, is being recorded, and you'll have access to the full set of slides. But I want you to remember 0.25 multiplied by n plus 1 for your lower quartile or your first quartile, and 0.75 multiplied by n plus 1 for your upper quartile or your third quartile data. Now, first of all, what is a quartile, and why are we what does it mean? So unlike the median, which is dividing your data into halves, okay? The lower quartile or the first quartile and the third quartile divide your data into 4 equal chunks, okay? So the first quartile is the first 25%, okay? Remember, we're doing it into 4 equal chunks. So it'll be 0.25. The next one, of course, is the median calculation, and the top one is your third quartile, which is 0.75. So these are the 2 that you need to remember as we go forward. Right, so how do they work? Because these are the kinds of, they can easily ask you a lower or an upper, or a first or a third quartile. They can easily ask you that in question 3 on your data stream for single data. Okay, so how are we going to do it? And this is quite important, class, because it's a kind of, there's 2 steps to the calculation, which is quite important for you to know. Right, so let's assume and I'm only going to do one of them, but I've got both of them here. But they're asking you for a first quartile data point on this stream of data. Now, as you can see now, this is very much a question 3. Why? Because you've got one long line of numbers, okay? Question 4 gives it to you in a table, a numeric frequency distribution. You will probably have it up to 11, okay? You won't have all of that, I doubt. So the very first thing you're going to do, depending on what they ask you, I'm going to work on a first quartile, is we're going to remember our formula, 0.25 multiplied by n plus 1. So the first thing we're going to do in this example, and then I'll talk to you about the ones in question 3, this happens to be 20, okay? N is 20. Why is n 20? Well, they're 20 data points. Plus 1 makes it 21. Multiplied by 0.25 will then give you in total 5.25. Now, this is important, class. This is a position. This is not a value. So now what you have to go and do is go and find the value at that position. Okay. Now, if it said 5.00, hey, that's not difficult. You go to 5 and you say it's 40. Great. But now there is a problem because there's a 0.25 you've got to deal with. You can't just ignore it. Okay. So the very first thing you're going to do is take the big number here. And you can see that 40 occupies position 5. So you put 40 down. Okay. Straight away. You got 40 there. But now you've got to deal with this 0.25. So what are you going to do with that? Now, this is what you're going to do. Right, so you go to position 40, okay? And then you say to yourself, what is, and I'm going to go very slowly now, what is my next consecutive number? Okay, so my next consecutive number is 43. Right, so now you're going to say, what is the difference between 43 and 40? And I'll explain why I'm doing this after I've done the calculation. So the difference between 40 and 43 is 3. So between 40 and 43, there's a difference of 3. That's when you bring your 0.25 in, because the question is asking you for a position 5 1/4. So there is 5 and then a quarter of the distance between 40 and 43. Okay, so now what we do is we take our quarter, 0.25, and multiply it by the difference between 40 and 43. And that, students, comes to 0.75. So again, let me say that to you. The difference between 40 and 43 is 3. But we are looking for a quarter of that distance. Why? Because we're looking for that. We've got the 5 because the 5 is the 40. And then we take the 0.25 and we multiply it by 3, which gives you 0.75. We then add it to 40.75 and we get our lower or first quartile data point. Right. So remember, rule of thumb, position, then data point. Position, then data point. Generally, they give you 11. So by the time you've gone to, well, let's say they asked, let's assume, okay, I'm just saying assumption now. Let's pretend that this data point ends at 11, okay? So 0.25 n plus 1, that would be 11 plus 1 is 12. And then multiply 12 by 0.25 would take you immediately to position 3. Okay, there's no 3 point anything. And then you would say immediately it was value 37 that occupied that position. So if they do give you an uneven number, it makes your life much easier because you won't get a decimal there. It's only when you have an even number that you get the decimals coming in to crop up. Okay, so remember, question 3. Probably the second or the third question will be a quartile, either quartile 1 or quartile 3. If it's quartile 1, you use that formula. If it's quartile 3, you use that formula. Find the position first by saying 11 plus 1 is 12. Then if it's position 3 or quartile 3, multiply by 0.75. If it's first quartile, n plus 1 is 11 plus 1 is 12, and multiply by a quarter. Okay, I think that's sorted. Any problems, just shout, put in a chat, or ask me and when we have a quick break at some stage. Right, lastly, for your question 3, before we get to the percentiles and quartiles on group data, they can ask you for a percentile. So let's stop. Question 3 is ungrouped data, one long line of numbers, okay? It's not in a table. The most general questions they ask you are going to be mean, average, median, first or third quartile, and percentile, okay? And in percentile, they can ask you jolly any percentile they can think of. So anything really between like about, well, it can be anything between 0 and 99, really, but they're not going to ask you 0 and they're not going to ask you 99. So let's assume they ask you the 40th percentile class, then you are going to use exactly the same formula as you used for your quartiles, but instead of the 0.25, you're then going to put the 40th percentile in there. So instead of that being the first quartile, they're going to then say 40th percentile, 0.04. 65th percentile, 0.65. 76th percentile, 0.76. I'm pretty sure you got it. Then what do? You do exactly the same process that I've just taught you. Put in the n, which will be 11, plus 1 is 12, multiplied by 0.4, find the position, then find the value. Okay, these are really easy. Don't, please class, you know easily how to do it. Just remember they may ask for an interpretation. So please remember there will always be an interpretation. So you will write something there about, if it was, say, for instance, the 25th, the first quartile, then you're going to say 25% of the data will fall below that number, whatever it happens to be. And for the 75th or the third quartile, 75% of the data will fall below that number. If they do ask for interpretation, don't forget it. Write something. Okay, just so that's something that your lecturer can mark. Remember that, please. Okay, so that's quartiles. Now we're going back to our color-coded grouped data. Question 4, okay? Not a question 3 type number. So now we are going to see that you will either have a quartile 1 or a quartile 1 or a quartile 3 question for group data. They will generally ask you one of those two along with a mode or a median, okay, for a question 4. And again, class, you're going to use exactly the same process as you did for the ones I've taught you with median, except this time you're not going to find a median value because you're finding the lower quartile value. The median value is half, okay? So logically, if you're finding a quartile 1, then you are going to find the first quarter, okay, which is 30. So let's just stop. A 30th, if they asked for the median, we know and understand that it's 30 divided by 2. If they asked for the first quartile, it'll be 30 divided by 4, okay, not 2 because it's first quartile. So we get 30 divided by 4, which gives you 7.5. Now we go exactly the same route again, and then we go to our cumulative column and find where 7.5 falls in. Remember, for your median, you wanted to find where your 15 fell in, because that was 30 divided by 2. Here, you're looking at your first quartile, because it's 30 divided by 4. Does it fall there? Nope. Does it fall between 3 and 8? Yes, it does, right at the end, but it jolly well does. So that there becomes your first quartile interval. And then, of course, you can then move forward and say, what's the lower limit of my first quartile interval? It is 20. Okay. And then you go and fill in the rest exactly as we did before. Also, a good rule of thumb, your 29 falls within the interval of 20 to 30. Great. And also quite an important kind of another way of finding out if you're kind of on the right track is this here. The 7.5th position is very close to the end of that interval here. 7.5 is really close to 8, and 8 is really at the top of that interval. So you would expect, kind of rule of thumb, that this number here will also be fairly close to the end of that interval, which is, it's nothing that you have to write down, but it would make you, if you are going a question 4 route, it'll make you feel a little bit more happier that you're kind of on the right track. Okay, so let's just recap before we move on. I'm dealing with question 3 or question 4 first in your paper. They are section B. They're the ones you are going to have a choice on. Question 3 and question 4 will deal with summarizing data, first of all, which will be the last question. You'll either be drawing a bar chart or a pie chart for question 3. You will be drawing up a numeric frequency distribution table for a question 4. Okay, moving on to summarizing and describing data or describing it. A question 3 will generally ask you for a mean, a median, a third or a first quartile position, and a percentile. Okay, and then a question 4 can ask you generally for a mode, a median, and a first or a third quartile. Okay, so now you can start getting to feel for yourselves or understand for yourselves, class, what you want to do. Okay, the worst thing, and I tell my own class this, the worst thing that you can do is get into that exam, do the first 2 compulsory questions, and then suddenly realize, I don't know which one I want to do. Now, you've only got an hour, students, so you can't waste too much time in humming and hawing about which one you're going to do. My advice to you is, after this presentation, after this masterclass, go back quietly and say to yourself, I know what I'm going to do. Either a question 3 or a question 4. Okay, please think about that. Right, we're going to move on. We will have a little break a little bit later. I know it's a lot of information to take in, but I've got a 15-minute, then I'm not doing it now, class, because I've kind of got you on a roll, and then I'll stop at the end of this. All right. So we got measures of central tendency. Then the last bit is measures of dispersion. Okay. So in other words, measures of central tendency is how the data is arranged around the mean, the average. Measures of dispersion, class, is how the data is dispersed out, whether it's tightly packed around the mean or is it dispersed out. Does it look like, hey, a tall skyscraper, or does it look like a soup plate, basically, what I'm trying to say. Now, you are going to have, or you can be asked, variance and standard deviation for both question 3 and question 4. Okay, you can be asked. Now, I'm telling you now, okay, that question 3 will generally always ask you for a standard deviation. Okay, now that's the one thing. If you go question 3 route, then you must, without any debate, be able to calculate your variance and standard deviation. Okay, please understand that. There is because if you think about it, a question 3 is going to be a calculation of a mean, a median, maybe a first or a third quartile, or a percentile. Class, you can do that very easily. They're very basic calculations. The variance and standard deviation, however, is the one area that is a little bit chunky for a question 3. So I'm saying again, if you go question 3, you must know how to do standard deviation without a shadow of a doubt. For question 4, it's actually more unlikely than likely. Okay, so let's start with a question 3 calculation. First of all, students, there are 2 ways of calculating it for single data, question 3. But I'm asking you, please, to use the one A they give you in the formula sheet. I don't think they even give you that. Well, if they do, it doesn't matter. You go this one, okay? This is by far the easiest one to use. And I'm going to show you, and I'm going to deconstruct it for you. By far the easiest one. If you want to go back and check in your book, go to page 88, go to formula 3.13. Okay, so let's move on and see how we do this. Right, so, okay, I don't know, on my own screen, because I'm sharing it, it looks a bit, it kind of doesn't look too clear, but I hope you can see it. And I'm pretty sure that if you want to, you can actually magnify it somehow or another. Okay, so here's your X column. Right, okay, and your X column class has 20 data points. You are not going to have 20 data points, okay? Remember what I've said to you. Question 3 generally has 11 data points, okay? Right, so you'll probably have 11 or at the maximum 13, all right? Now, what are you going to do? You are going to say, and that's all they're going to give you, hey, is that, which is the same data that you're working on from your mean, your medians, and all of that. Okay, it'll come from, the number will come from the same data stream. They're not going to give you a different data stream. There is your calculation. Now I'm going to go through this calculation really slowly because I know from my own experience with my own students where you make the easiest and most careless mistakes. All right, and I don't want to see you doing that. Let's get distinctions here. Okay, so let's go for it. There it says sigma x squared. Okay, now class, if there's nothing else you kind of remember from today, please remember what I'm about to say to you now. X squared means you take each x and you square it first. Okay, each x, square it, then add it. You do not, please, and under any circumstances, add up all your x's and then square it. Okay, that is not going to give you the right answer. So let's show you. So I'm going to speak to the formula and then I'm going to show you how it works. All right. So formula, x squared sum minus n, which in this case is 20, but in your case is probably going to be 11, multiplied by x bar is x average. Okay. Now remember, you will have already worked out the average probably in the first part of the question. So you don't need to work it out again. Just make sure that the average is correct. Average squared, okay? Average squared, all divided by n minus 1. So let's do this side of it first, then let's do that side of it. What have I said to you? Take each x, square it. 58 is squared. 50 squared, 33 squared, all the way down. All the way down. Then and only then do you add it. So that is your 45276. That goes there, which is there, minus class. And I've done the calculations here and I've deconstructed them. N is 20 in this case, not in your case, multiplied by the square of the average. Now this average happens to be 46.9. In other words, how do I sum an average of ungrouped data? I add them all up and I divide by, in this case, 20. In your case, it'll probably be 11. Okay. And I get 46.9. So now I'm taking n, which is 20, multiplying it by the square of 46.9, which the square of 46.9 is 2199.61. Okay, so now what I've done is I've done each step for you here, and then what I'm doing here is multiplying it out for you. So that 2199.6 is now the square multiplied by 20, which gives me 43,992. That's my top, that's my numerator, divided by my denominator, which is 20 minus 1, which is 19. In your case, and some of you are going to get irritated, but I'm going to keep saying it, it'll probably be 11 minus 1, which is 10. Get to that number. That number class is 67.58. Now remember, you do not stop there. That is your variance. That is not your standard deviation. Your standard deviation, bright sparks, is the square root of that. Because remember, and just for what it's worth, so that you understand kind of why we do that, here we've been squaring the numbers to get rid of all the negatives and whatever else may be in it. So naturally, when you come to the end of this process, you kind of got to unsquare it. And we are unsquaring it by finding the square root. Okay? And the square root of the variance is your standard deviation, which is 8.22. Now, okay. Now, I'm not going to go over it again. I think most of you can see it. You can be able to see it again on the download. It'll be on some YouTube channel somewhere, but I'm asking you, and I'm not actually asking you here, I'm telling you, if you do question 3, you must know how to do this calculation. Okay, how you to do it, not from your calculator, Bright Sparks, but from the calculation, because your lecturer is going to mark this formula here. He is going to, I think, 50. Sorry, Jessica, I'm not. Okay. All right. I'm not quite sure what you meant there, but okay. Here, you are going to make sure that you do the calculation in all of its glory, if I can say that. All right. Okay. Now, what I'm going to do is I'm not actually going to do the variance for group data at this stage, class. I don't think at this stage it's necessary. I would rather you concentrate on mode, median, and your quartile calculations. All right. That kind of brings you'll see it. And if there is time at the end, I'd rather do the really pertinent stuff and then come back to this if it's necessary. Okay. Oh, yes, sorry. Hang on. Before we have a quick break, I'm going to stop soon. Coefficient of variation. Class, this will come up in a question 3, okay? Or even a question 4. There is just, this is they'll give you this, it's in your formula sheet, and they'll ask for the coefficient of variation as one of the final questions in either question 3 or question 4. What does it do? It means, and they can only ask it after you've calculated your standard deviation, right? So you're going to get that number you've just calculated and divided by the average, and then you will make that, and this is important. It's actually my bad, I haven't put it on here. Make it into a percent. So let's assume this was a 10 divided by a mean of 100. Let's just pretend that. So you got a standard deviation of 0.1, which you are then going to multiply by 100 and get you to 10%. So if they do ask you for coefficient of variation, please class, put it into percentage terms. All right. Okay, that brings you to the end of the section B section of the exam, which is going to be, as I've said to you, either or, question 3 or 4. I'm going to give you a quick 5-minute break, okay? No more than that, because I don't want to waste your time either. And then we're going to start with regression, okay? And I'm going to show you what to do, how we're going to do it, and then after that we'll take it on. So give yourselves 5-minute break. So it is now basically 1 o'clock. Please be back, or get yourself a coffee or something. Please be back by 5 past, because I'm going to start bang on, and then we're going to try and get you guys finished by 2 o'clock latest, because I do know you have other stuff to do. Okay, if there are any questions, now's the time maybe to ask, or put it in chat if you want to, and then we'll move on. Okay. Sorry, I understand where Jessica comes from now. The test is out of 50. The test is out of 50, okay? Yeah, Regan, I will, if you will grant me, yeah, okay. Let me finish what I'm going to do, and then I will show you right at the end what needs to be done, okay? Right, students, I'm going to continue now. I don't want to waste your time. I know that you are busy. I know that you've got a lot of exams and things coming up. So what I'm going to do now is I'm now going to start with a question one. Okay, so we've dealt with the either or type questions, question 3 or 4. Now I'm going to deal with regression, and that'll be a question one. And regression will have probably 2 or 3 components to it. The first one will be that you need to calculate the line of best fit. You will need to show calculations with that. I'm going to show you how we do that. Then they are going to ask you for some form of a prediction. And then generally they ask you to calculate Pearson's coefficient of determination, and that you will have to use your calculators for. Hopefully, your lecturers have shown you how to do R and R squared from the calculator, because that's difficult for me to show on the screen here. But I can show you the first 2 components. If you do get stuck, I can just email me. I'll show you the email. I'll give you my email, and then I'll send you a link to YouTube where you should be able to, it'll show you very easily what you need to do. Okay, so let's start. We know that the aim is to find relationships between 2 random variables. Okay, so you got an independent variable and you have a dependent variable, and that's very important. There's an x and there is a y. The x is the independent variable, the y is the dependent variable. So if I can start here, because this is the important part, this is your linear equation. So this is the thing that you're eventually going to pop out with. It's going to be your line of best fit. Okay, and the x is going to be left on its own because that's where you're going to use it for prediction. There's an A and there's a B. For those of you who are aware of maths, you know that, or not aware of it, you're used to it. This is a slope coefficient. That plus means it's upward sloping. If it's a minus, it's downward sloping, and this is your y-intercept. That's not critically important for us at this stage. What we need to do, they will give you the formulae. We need to fill in the B and the A. That becomes the line of best fit. Once we filled in the B and the A, then class, it becomes easy to get that line of best fit. All right, so why do we do B first? We do B first because we need B when we're calculating RA. So moving forward, here's an example. It actually is very much an exam type example. We have age in years and income. The income is the dependent variable, so that's what your Y is. Your X is the is an independent variable. So income is a function of age and years. That's what this is saying to you. So it says table indicates the ages of a sample of female, etc. Determine the linear regression function for this data set, or the line of best fit. They can use either of those terms. And then if a female is 38 years of age, estimate her monthly income. So they give you that. Okay. Now what they're going to say to you is also create in your test book, please, and this is important, also create in your test book an x squared column and an xy column. Now, the reason they ask for that, students, is because you can see from the formula B that if you do that, you're going to have everything you can to fill in there. Okay. And remember as well, from a marking perspective, you need to show this in your exam book because these down here there are marks attributed. So you've kind of got to show that. And the marker is going to definitely to show you that. I mean, the marker is going to require you to show this in order to get the numbers. Okay, right, let's do this now. It's quite important. So we have an n. First of all, class, n is the number of data points, or in this situation, coordinates. Okay, that's a coordinate, a set of coordinates. That's a set of coordinates. That's a set of coordinates. There, and there. How many sets of coordinates do you have, class? You have 1, 2, 3, 4, 5, 6 sets of coordinates. That is where that 6 comes from. That's where that 6 comes from. Right, then it says sigma xy. So let's go to sigma xy. And we have, so we get, so what's it actually saying? Take your x, multiply it by your y, and get a number. And that's saying do that and then add it. So that's 11080. So in that term there, we get that and put there. Minus sigma x. There is your adding up your x, 256, multiplied by sigma y. Add up all your y's and get 254. So we got the top, we got the numerator. On the bottom, we've got 6 sigma x squared. Take your x, okay, right? Now here's two things here, class. You've got to remember, there's sigma x squared. What does sigma x squared? Remember, please, from that previous example I showed you with variance and standard deviation, sigma x squared means take each x and square it. Take each x and square it and then sum it. So we have 11266 when we have taken each x and squared it. Then confusingly, it then asks you to take your x square, then square the sum of x, which is not the same as that, as I've just explained. So with this one, you take your x, you add it up, then you square it. Okay. Once you've done that, then this is pretty simple for you. For all of those with your Casios, you're going to get b is equal to 0.71. Great. Okay. Moving on. Now we've got the b. Now we can find the a. So now they're going to give you these formulae, class. So we go, there's our b, and we stick in the 0.71 from this calculation. And we then say sigma y, go to y, there's 254, stick it in there, minus 0.71 multiplied by sigma x, which is 256. We get our a. So now, students, we've got an A and a B. Now we can fill it in to our formula, which is y equals A plus BX. We've got our A, which is 12.04. We've got our B, which is 0.71. That becomes, students, the line of best fit. So on a scatter curve, that is the linear equation that minimizes the deviations from the mean. Crudely, don't worry about that too much. Now the second part of the question said, if a female is 38 years of age, estimate her monthly income. Now you're pretty sorted, because now they've given you the x, okay, because x was years, and you stick it where the x says there, okay, and then you just sum it. I mean, you multiply it and sum it. That comes to 39.02. But now this is the bit that most students forget and gets them to lose marks. I want you to go back to the question. Okay, the corresponding monthly income of each employee in thousands of rands. So you've got to take your number, and you remember, this is in thousands of rands. But you've only been working with this. You haven't been working with it in thousands of rands. So now this number here must now finally be reconverted to 1,000 to the thousands of rands. So now you take that number and you multiply it by 1,000. Okay, 39,020. So that's question one. That'll be the first two components of question one. The third component of question one will very possibly be, please get using your calculator, right? Using your calculator, find your r and your r squared. And as I said, that's really difficult for me to show you on here. So please go, maybe find it on a YouTube. If your lecturer should have shown you anyway, quite honestly. But if he or she hasn't, for whatever reason, go to YouTube. If not, I'll give you my email at the end of the address at this, and I will send you the link anyway, so it can help you. All right. Now that's linear equation. So that'll be question one. Now remember, Jessica asked a very relevant question. What is the thing out of? It's out of 50. So class, you are going to have to work a little bit, because they're going to ask, the content hasn't changed, okay? So in the olden days, you got a couple more marks for working out, which you're not going to get now, because in the olden days it was 60, now it's out of 50. So what I'm asking you to do is make sure you answer everything very fully, because marks are going to be a little bit more scarcer now. Okay. On the plus side, of course, you're not doing a mark a minute now. You're doing slightly, your marks is slightly more than a minute for a mark. Okay. But please remember that. Okay. So moving forward, now we've had our coffee break. We can now move forward finally to question 2. All right. Question 2 of your paper. So question 2 of your paper is going to have 2 kinds of probability questions. One, using a frequency table, or 2, using a probability tree. Okay, I'm going to go through both of those, and then I'm also going to discuss a couple of questions they generally always ask. Okay, and I'm going to go through them very briefly. So probability class is the key concepts. What they are going to what they're going to examine you on is marginal utility, an addition rule, maybe intersection, multiplication rule, conditional, or complement. 1, 2, 3, 4, 5 concepts are going to be examined on how much you know. Now, how are they going to do this? Okay. Now, the easiest way they're going to do it, class, is through, I can come back to these. This is just additional information. They are going to ask you, they're going to give you this. Okay. So let's just shoot straight through to what they're going to give you. They're going to give you a table on the one type of question. Okay. And on that table is going to be males and females probably, and then whatever at the top. This just happens to have stores. And then they're going to ask you 4 types of questions. Okay, and by doing that, they're going to test your knowledge of each one of those concepts. So that's a marginal concept. This is a multiplication concept. This is a conditional concept. This is addition, and that is complement. So the 5 concepts are now going to be examined or tested by 5 types of questions. Generally, you will only get 4 types. You'll only get 4 out of the 5. Okay, but I'm going to go through all of them anyway for you to just make sure. Now, with my own students, the easiest way for me to teach this is my so-called eyeball approach, which is to actually look at it and work it out from looking at the table. You can use the formulae, and I will show you where the formulae are as we go through it. I don't suggest you use a formulae unless your lecturer has taught it to you, which is fine, no problem, because sometimes the eyeball method is actually easier. Before I move on, I want to just make sure or just indicate to you one further important point, and that is this. There's each one of those concepts has a keyword, okay, which tells you what kind of concept it is. So the keyword for intersection is and you'll also find it in your book. The keyword for conditional is given. The keyword for addition is or, and the keyword for complement is does not. And they will always not be the same. Even if you draw them off, you can go back in papers class, as many as you want to go back, and you'll see they all have the same keywords. So once you know the keywords, it gives the key to the way you answer the question. All right. So let's start. The very first one, what is the probability of randomly selecting a female respondent from the sample? This is a marginal probability class. In other words, it's like me saying to you, here's a bag of marbles, 10 are green, 10 are blue. Mix them all up randomly, and what's your chance of pulling a green one out or a blue one? What you've got here is a bunch of people, and now you're asking what is your probability of pulling out a bunch of people who are either male or female. What is the probability of pulling out a female? It's exactly the same. So it'll be the number of females in that cohort or males, and then divided by the total cohort. Okay, and that comes to, now remember here, please always take your number to 2 decimal places. Always take your number to 2 decimal places, please. Okay, it's going to go to 1% to 2 decimal places, and that's 31.25. This is a probability. Always remember, class, as well, the properties of probabilities and the fact that you can never get a probability that's either negative or over 100%. So if you get either of those, you've done something wrong. That's the first question. Number 2. Right, you will see I've got an eyeball method and I've got a formula method. All right, I'm just showing you the formula method. When you pull this down, or if you do wish to download it from a little bit later today, you can go through both. I've done it for my own students, but the eyeball method is by far, in my humble opinion, the simplest. So, right, we have highlighted the and. The and is an intersection. And the way I describe it and teach it to my own students is, what is an intersection? It's a meeting of two roads. And at the intersection, the two roads meet. So now you have two roads. One of them, well, the one identifier is male and the other identifier is Woolworths. Okay, so let's do that. So we're going to look at them as if they're roads. There's a male, there's the male, and you go all the way along till you intersect with the road which is called Woolworths, and that's 125. And you're going to take 125 and you divide it by the total, which is 400, gives you 31.25. If you wish to, class, you can use a formula method. And remember, I'm talking nationally now. I have no idea what your lecturers have asked you to do. If they require you to do the formula, then you should do it. Although, having said that, the memo itself doesn't prescribe a formula. Okay. So, in my opinion, and it's only in my opinion, you can do either of them. Okay. But again, without stepping on toes, I don't know what your lecturers have told you. Okay, so it's 31.25. If you do the eyeball method class, you get 31.25. You can go through it a little bit later if you wish to. Next question. What is the probability of randomly selecting a female respondent given that the preferred supermarket is Checkers? Okay, given that the preferred supermarket is Checkers. This is a so-called conditional statement. The given makes it conditional. Now, again, class, you can do eyeball or you can do formula. Here, I've just given you the formula, but I want to show you the eyeball method because this is something, please to take note. All the other probabilities that you are calculating at the moment are all going to have the denominator as 400. The conditional is the only one that does not have the total cohort as a denominator. In other words, the number here doesn't go on the bottom, and I will explain why that is in the case. So the question is, you've got a female respondent and she prefers Checkers. It is given that she prefers Checkers. Therefore, you're going to go females to Checkers, and you know that that's 50 because it tells you. But now you're not going to divide it out of 400. You're only going to divide it out of 110 because the preference is for Checkers. So in an eyeball approach, you will go, it's very much like an intersection, but you don't go the 400, you go the 110. If you wish to do the formula class, there is the formula, there is the, and that's what you will do from an eyeball approach, and that is what you will do from a formula approach as well. So it's your call completely. All right. And then finally, this is the one actually that they don't often ask, but if they do, you actually have to calculate it, unfortunately. This is the one non-eyeball approach, is that a respondent who is male, who is female, or who prefers pick and pay, or both. Now remember what I said to you, the given is conditional, and is multiplication, or is addition. In other words, you're adding everything up. So the actual question is asking you, what's the probability of finding who's female, or who prefers pick and pay, or both? So the whole lot, and you're going to add the whole lot up. So you're going to use the addition rule, which happens to be that. And then what are we going to do? So the probability of a female is 125 out of 400. What's the probability of people who prefer pick and pay? That is 150 out of 400. And then, of course, as perhaps you would remember from lectures, is you remove or you take away the intersection. The intersection is females and pick and pay, which is 60 over 400. And then you would do the calculation and get 53.75%. But again, class, they don't often ask this. They always ask marginal. So let's go back quickly. They will tell you they always ask one of these type. They always ask one of those type, and I'm sorry, and then they always ask one of these, okay? And finally, they always ask one of those. Who does not, which is the complementarity. So, I mean, it's pretty simple. You've got one of two approaches, in my opinion. A respondent who does not prefer checkers, so you're going to find the probability of checkers, which is 110 over 400, and then minus it from 1. Why do you minus it from 1, class? Because this is this is a totally exhaustive cohort. That all adds up to 400. That all adds up to 400. So if you find the probability of checkers out of that, then 1 minus means it will be the probability of Pick and Pay and Woolworths. Because think about it, that plus that is 400 over 400, which is, hey, 100%. So if you're only finding the probability of checkers, class, then you are finding a component of that 100%. So 1 or 100 minus that must come to the complement rule. It's not too difficult. They generally ask you this question. So it'll be question 2 in your test, and they will generally start off with a table. Okay, if they don't do that, they will ask you a probability tree, which we will deal with. All right. Now, before I move on, I want you to be aware of a question they basically always ask. Okay, class, they always ask this. So I'm asking you to know how to deal with it. So they'll say to you events X and Y are such that probability of X is 0.2 and probability of X union Y, or the addition, is 0.55. Given that X and Y are independent and non-mutually exclusive, determine PY. Answers to 2 decimal places. Right, this look, I can't say I don't know, but on average, 90% of the questions that have a frequency table also have one of these. Okay, so I'm asking you to prepare yourself for it. Be prepared for this type of question. Okay, like be prepared if you do a question 3 to be able to calculate the standard deviation and variance. So what are you going to do? Well, the first thing you're going to do is you're going to put the thing into some form of formula or relation. Now, they're asking you for an addition, so you're going to use the addition rule, which is X, it should have been capital, sorry, X union Y is equal to PX plus PY minus PX intersection Y. That's given to you. That's axiomatic. However, now this is the point. They gave you 0.55. They gave you 0.2. They did not give you the intersection. So you can do absolutely nothing with that, actually. Well, you can kind of fill in 0.5 and 0.2, but that's about as much as you can get. So you need to transform this into something else. And you do that by using your independence assumption, okay? Because they've told you, if you go back here, they are independent. So if the events are independent, class, then you can transform that into the independence formula, which is px multiplied by py. Now you're sorted. Because now what do is you substitute your numbers in. 0.55 equals 0.2. That is what they gave you. Plus py, okay, that's what you've got to find, minus 0.2. Why is there a 0.2? Because again, that's a px, that's a px. I'm substituting 0.2 wherever I see a px. Okay, so now we've got that. Now it's a question of just algebraically solving it. You take your 0.2 onto that side, that would be 0.35. Okay, and then you're left on this side with py minus 0.2 py. Okay, so that is, you factorize, it'll be 1 minus 0.2 effectively, okay, which is what you've got here. So now you've got 0.2 taken across there. That is 0.35, okay? Then you've got on this side, you've only got 0.8 left because it's 1 minus 0.2. And now it's simply a question of getting rid of the 0.8 here. Divide by 0.8 there, divide by 0.8 there. So you get 35 divided by 0.8 is equal to 43.75 or 0.4375 as a decimal, multiplied by 100, and you get to 43.75. Okay, so class, just know that. Just be able to do it. I'm sure your lecturers have gone through it. But it's in front of you if you need help. Right, almost done, I promise. Last one. Here is an example of a probability tree. Okay, so if you don't get your frequency table, you're going to get a probability tree. So a bag contains 9 green and 11 blue marbles. You're asked to select 2 marbles from the bag. The first marble selected will not be placed back in the bag. Construct a probability tree. What is the probability of selecting 2 marbles? Let's do the construction first. Sorry, this is not as good as it should be, but hey, let's try and work through it. So the probability tree is going to have the first 2 arms, and then it's going to extend out again into two, because what you're doing, class, is you've got a bag of marbles and you're going to dip your hand in. Okay, so you dip your hand in and you can either get a green or a blue. Okay, so there's nothing else you can't take out. You're not taking out 2 at a time. You're taking out 1 and then another one. So you take out, let's assume you dip your hand in, class, and that's the probability of finding the first green is 9/20, or 45, or 40%, or 45 or 55%. Right. So let's assume you put your hand and you pull out a green one. Okay, and you put it and you don't put it back. Now you go back again. You don't have 9 green ones. You only have 8 green ones left because, hey, you've left one outside. And now you've also taken one out of the bag, so you don't have 20 left. You have 19 left. Okay, so that's what happens when you work on that branch. Here, you still have, hey, 11 blue marbles, but again, there's only 19 in the bag. So that's your first branch and second branch. Then you can go down this way. If you had put your hand in and this time you didn't take a green one out, but you took a blue one out, then and you put it behind you. So now what's happened is the probabilities have changed because now the blue one's out. So now you only have 10. Instead of 11 blue, you've only got 10 blue. And again, you've only got 19. So these probabilities have actually readjusted depending on which color you have taken out and what their weightings are. All right. So that's the probability tree. You're going to put your outcomes, which is, remember, they're independent events. Why? A marble has no memory. It doesn't remember what the previous color was. And you multiply them out, green to green, green to blue, blue to green, and blue to blue. And you're going to get those probabilities. All of those probabilities, class, will sum to 1, hopefully, if you're right. That's the first part. So that'll probably be 6 or 7 marks. They are attributed generally half marks each, and then marked for each one of those outcomes. When you move forward, moving here to what is the probability of selecting 2 blue marbles, what are you going to do? Well, you can read it off your tree now. That's green and green, that's green and blue, that's blue and green, and there's blue and blue. So this probability and that alone is the probability of pulling 2 blues out. And you're going to multiply that probability, 11/20, multiplied by 10/19. So that arm and that arm, and it's going to bring you 28.95%. That's if they don't ask you a frequency table. So you'll either get a probability or a frequency table. All right. So that'll be the first part of your question 2. Right. The second part of question 2 will be one of this type. Or, class, they can ask you finally a permutation or a combination. All right. So, and I'm not sure how they're going to mix and match it. So it's not a bad idea to know both. So a combination, well, first of all, what are we trying to do? It's really counting rules. So we've got a big set of data or numbers, and we're going to pull some of them. So for instance, the general kinds of questions are, is John has a team of 15 people, okay, and he randomly pulls out 5 for a trip to Johannesburg. What is your probability of finding, or what's the probability of you pulling out the same team as he does? Okay, not in the same order. So you got 15 names and you pull 5 out. Or it's in fact exactly the same as the lotto. Okay, so the lotto is exactly the same type of a combination example. You have 49 balls and you draw 6 out of it. But generally they won't ask you a lotto. It'll be a team. So it'll be, and it won't be these big numbers either. Hey, it'll be a team, say, of 15, and they draw out 6, and 6 people are chosen. What's your probability of choosing the same as that, but not in any particular order? So you're going to use your combinations formula, which is n factorial over r factorial, or this can also be an x, n minus r or x factorial. Your calculators will do the factorial calculation for you very, very easily. Remembering factorial, for instance, is 3 if it's, I say 3 factorial, it's 3 multiplied by 2 multiplied by 1. Okay, never by naught. Okay, and always remember as well that 0 factorial is also equal to 1 factorial, which is equal to 1. Okay, in this example, with 49 balls and 6 numbers, your chance of actually winning the lotto is 13.98 million to 1. So you can understand why gambling is, or the lotto is look, you're in with a chance, but a 13.98 to 1 chance of getting it. Numbers go up dramatically as well if you change that to 52 balls. All right, so that's a combinations. And then finally, a permutations is where order does matter. There's your permutation formula. What have we dropped here? We've dropped the R factorial. And the kind of question they ask, there are 4 teams in a darts competition. What is the probability of correctly predicting the first 2 teams, in the correct order? You're going to put in 4 there. You're going to put 4 there minus 2. So it'll be 4 times 3 times 2 divided by 2. So your probability will be actually not 12. That's not a percent. It'll be 1 in 12. The ability to be able to do that. All right. So question 1, compulsory. Question 2, compulsory. Question 1, linear regression, asking you to calculate a best fit line, asking you to do a prediction, also asking you to find an R and an R squared kind of. Question 2, class, generally a probability, either a frequency table or a probability tree with a selection of questions such as the one I showed you and combinations and permutations. Section B, question 3, or question 4. Question 3 is descriptive ungrouped. Question 4 is descriptive grouped. With question 3, they'll probably ask you mean, median, percentile, and quartile. First or third quartile. Definitely standard deviation. Okay, I can't keep making that. And if it's grouped, generally either a mode or a median or a, well, sorry. It'll be a mode and a median and a first or third quartile. Okay, it'll all be out of 50 and for 50 marks. Okay, you guys and girls, well done. I hope it was of some help to you. I'm going to get it all busily loaded now. I'm going to stop the recordings now. I'm going to get it all busily loaded. It should all be accessible again for you fairly soon this afternoon.